My name is Charlie Portelli. I'm a member of Core Studio, and this talk we're going to highlight, some of the hackathon projects, specifically the winning projects. I've attended all of the AEC hackathons since before I was a part of Thornton Tomasetti, and I really enjoyed them. And this year, we had to do something different, and we basically had to take this digital. Um, the great thing about this is that we had around 91 individuals that had registered for the hackathon, so the numbers keep growing over the years. Our participants come from all around the world. There's about 10 to 15 different countries and a number of different cities around the world, anywhere from like London, Kuala Lumpur, Netherlands, Vienna, Barcelona, Tokyo, Chile. So we're spanning, almost all the continents. If someone wants to move to Antarctica next year, so that we can include that continent, we can check off all the continents on our list. There's some criteria, obviously, for deciding the winners. We start to look into who is leveraging existing technology for new uses. Is there anything that's groundbreaking that's coming out of this? We always try to help contribute back to the community. So we always want to encourage all the solutions being open source. We also look into how much did the team actually learn? Is it just something that they already knew that they showed up with? Is it something that they already knew that they showed up with, or is it something that they wanted to learn and kind of push themselves? And then we also look at the diversity of the team, right? Trying to really get a good mix across the board. And we've had individuals from architects, engineers, contractors, fabricators, independent consultants. We've had individuals in previous years who were just tech folks that weren't in the AEC space and kind of just contributed to the hackathon. So collaboration is a big one that we look into. So now moving to the three winners. So first is best collaboration. This was given to Layout 5. And the idea here is that they wanted to be able to bring environmental analysis in the early stages of the project. So how can they essentially sketch out a floor plan and be able to get informative analysis to help for their decision making? These are the 4 team members: Theodoros Galanos, Ping Hansen Chen, Peng Wang, and Yoran Janssen. These are the folks. An idea, again, is to be able to get real-time or quasi-real-time recommendations on your floor plan layout that takes into account some daylighting metrics. So they used essentially pre-trained ML models, one for finding nearest neighbors, another one for computer vision, and then there were some post-processing scripts to essentially streamline the evaluation process. The team looked into 3 qualifying aspects, obviously looking at daylighting performance, total area, and the number of windows. They took the first step of prototyping this to essentially give themselves a quick proof of concept. And they used some of the more common tools that are in our industry, things like Grasshopper, Human UI, some Python ML, and then Rhino Compute. And this should play perfect. So the idea is that they can, in real time, sketch out very basic floor plan, and then that the application will start to suggest certain arrangements of the different spaces in the floor plan. And that will also start to essentially suggest kind of window locations and so on. So you can see there's various different rooms all around the perimeter. and the circulation space is kept more towards the interior of the plans that are being suggested. And here's another example of laying out some of those spaces. The team also showed another example of being able to shift the windows around and so on. So the next category was best open source, and that went to GANPlan. The idea here was essentially to start off with some research that was kind of already predefined. So Autodesk had released a paper talking about the ability of using machine learning for associative space planning. These are the team members, again, varying across the board. Demi Chang, Mark Hogan, Leland Curtis, Brandon Puchka, sorry if I pronounced that incorrectly, and Matthew Bro. This is the paper that they referenced, and essentially this talks about identifying using again a generative adversarial network that's constrained by a graph, and the reason there is that they wanted to use this idea of having a series of rooms, which are the bubbles that you see on the top left diagram, and then the connections between rooms. And that associativity essentially starts to generate what would be the floor plan. So as you go from the top left and you work your way to the right, this associativity through the GAN starts to work itself out to becoming a floor plan. They developed a web interface which allows the end user to populate the different rooms, assign the connectivity. In the back end, they have a Flask server, Python server that uses the data from this paper that was published. And then they have a front end interface. So they're able to take this data that's generated, these floor plans that are generated into the Rhino environment. And of course, they all love coffee. We try to make these hackathons fun. And then lastly, we have our best overall hack. And this went to the Easy EC team. This was a project that essentially wanted to make the concept of identifying embodied carbon in the design process fairly easy, and kind of move that forward, shift it forward in the design process. So as we start to design these buildings, we can get early indications of where we can start to make changes. And this is a team: Andrew Schwartzel, Luke Garon, Patrick Wazowska, Emil Poulsen, Luke Lombardi, Chris Hazel, and Brittany Holmes. And they start to talk about the fact that there's a lot of different sources where data has been compiled over the years for embodied carbon and so on. And a lot of those sources come from disparate locations. About more than half of the kind of CO2 emissions comes from the building industry, right? So building operations and building construction. So they wanted to look into how can they essentially use that data to change that percentage of the pie that you see in the image on the left. So we're all familiar with the McLeamy curve when they talk into the concepts of BIM and how there's opportunity. The cost for change is significantly drastic from the beginning phases to the latter phases of the project. And in the latter phase of the project, it's a little too late to make changes. So this team essentially wanted to shift that and kind of bring the ability to make change or informed changes in the earlier stages of the project. So they looked into the data a bit more, and structure, facade, and so on are essentially a large part of that other pie chart. So if you took that more than 50% being the building industry, and you kind of subdivided that, facade and structure is a big part of that. So here they start to look into some of those kind of sources, one being, for example, the EC3 building transparency, which lists essentially a lot of data around various different materials. And then there's also a research tool developed by Payette called Kaleidoscope, which essentially starts to make some of that data also transparent. So they started by looking into this web platform called Swarm, which essentially allows them to very quickly drive a 3D model of facade and structure with some inputs and some outputs. And they were essentially able to take all of that and put that into what we see here as a web interface. So they can control, different design options using some of those sliders in the Swarm interface. And then you see the results on the right-hand side as a pie chart. So you pick your materials, and you can understand the CO2 that's part of that design option. And with that, perfect. That any questions?
All right. Thank you, Charlie. This is Ben, also from Core Studio. I'm gonna moderate this little session. So I have a couple, if there are any questions from the audience, please either hit them in the chat or the Q&A. And also just a little reminder from Shannon in the chat, we're switching webinar links after the break, so just make sure to catch that. All right, so Charlie, I had a couple for you. There are a number of projects this year and last that incorporated machine learning hackathon projects, including the one you worked on this year. So I'm curious from someone who's been in all of our hackathons ever since we started, how do the machine learning projects differ from one like this, the Easy EC, which is kind of more of a kind of pure applied computation project?
Yeah, that's a good question. The number of machine learning projects within hackathons that I attend continues to grow and grow. Some of them look into replacing the designer. Like, these are tasks that a designer does, let's replace them and let's let a machine do it. And then some of them look into, they acknowledge the fact that technology is here to stay, it's not going anywhere, but also humans are here to stay and we're not going anywhere, unless we develop a robot that takes us out. That's a different story. So some of these machine learning solutions start to look into the pairing of machine and human. How can we use the machine to enlighten the human's thought process, and how can we use the machine to educate the human, right? There's a lot of these solutions where there were a few plan generators yesterday that were presented, and I think in the Autodesk paper they went through 117,000 different floor plans, right? And yet the machine still generated a floor plan that was, there was a bathroom in the middle of the living room, right?
I know. Yeah.
It takes a junior architect can understand that you don't put a bathroom in the middle of the living room. Like, it only takes them, a few minutes to understand that, right? So to think that the machine is fully going to drive us may not necessarily be the right case. But if we look at pairing up with the machine to generate, a solution that's beyond what we can think of, or beyond the data sets that a human can kind of wrap their head around, we might be able to achieve something better.
So do you think it's ready? I guess that was my other question, like in a hackathon. That's been the main change Luis mentioned in our chat. Like, there were 0 interop projects this year. A couple of years ago, it was Rhino inside everything, nothing but interop, or kind of like integration projects. do you think the maturity is there? Are we getting ahead of ourselves? I'm always curious. I mean, I was really struck by the number of machine learning projects yesterday. There was like a handful of plan generators, or a few at least.
Yeah. Is the maturity there? Probably, I'm going to say probably not
Yeah.
yet. Machine learning is a big topic in the world in general, let alone architecture, right? If you want to use computer vision to identify avocado toast or a cat, there's tons of really well-trained models, right? Because that's what everyone out there is doing. But because our industry is so specific, to generate a floor plan, that only affects, people in the AEC space, which is a small percentage of the global people that are working on machine learning, right? So we have to, do our due diligence and earn our stripes essentially till we get models that are really informed, that can inform our industry, right? So it's just a matter of time.
Excellent. Okay, so we have a little chatter in the chat here. Rob said there was one interop project. The plate some progress, and then a question from the audience. I think for the Layout 5 team, what daylight analysis methods did you use? Do you happen to know, Charlie? I don't know.
Off the top of my head, I don't know, but you were on that project. If you can
Answer
chime
in
in
the
real quick.
chat.
Yeah.
There you go.
They were looking at daylight, a simple daylight factor prediction. There you go.
All right, Charlie, one more for you. I'm sure we're all ready to wrap it up here. So this was our first virtual hackathon, and of course we missed some of the, the in-person experiences. What do you think? What were some of the upsides from your point of view? And follow up, do you think you could spot the difference between kind of an in-person hackathon project versus a virtual?
So the first part of that question, how the virtual versus in person. I think one of the pros of the virtual is that I'm going to speak from personal experience. It
Yeah.
allowed me to stay more focused. I knew who my team was. We had Zoom calls or Ring Central calls or Slack calls, pretty fluidly. So we were able to really focus in on a solution, and that there wasn't the extra chatter. And not that chatter is bad, because it actually is good to catch up with some folks. But I think that was one of the pros about being to have it virtual. And then to answer the second part of your question about, would I be able to spot a project that was done virtually versus not? I'm going to say no. Because
I'm curious too. I think a lot of people here have been trained where like process matters. It's all about the process, and the process imprints itself on the work. I'm curious if it does for hackathon projects. I'm kind of with you. I don't know if I saw it yesterday.
Yeah, other than, a photo like, where is it? I'm trying to find.
Yeah, I do like the screenshots. Those are some of the best photos we ever get. We usually don't get a team photo, right?
Yeah, exactly.
All right, beautiful. Any other questions? I think that anything else in the chat or Q&A from people?
Yeah, I think there was just one comment about, hackathons are an excuse to explore, and I totally agree.